Hi, I'm Jonathan Aldrich, and today let's talk about LR parsing challenges. So a famous parsing challenge from ALGOL, which is an early programming language that influenced a lot of later languages and included the development of parsing techniques, involves if then else. In a lot of languages, starting with ALGOL, the else is optional. So we can have a statement of the form if expression then statement, or a different form, if expression, then statement, else some other statement, right? And of course, there's other statement forms, but we'll just look at these for now. So consider the following phrase. If expression, then statement, else statement. So we've got two thens, but only one else. Which of the then clauses does the else belong to, right? Which of the if statements does this else match? It could match the inner one, or it could match the outer one. So in terms of LR parsing, this is called a shift-reduce conflict. So let's look at the parsing state, right? We've read if expression, then statement, and we've got an else, and we've got two things we could do, right? When the next else appears, we can do a shift, which treats that else as if it's part of the inner if statement, right? Because the thing we're parsing right at that point is the if statement, is the inner if statement, and then the outer if statement is like, further out in the in our stack, right? Further down the stack, basically. But there's another thing we can do, right? We can reduce the inner if statement. We can reduce if exper then statement into a statement, and then we can continue parsing the else, right? In which case the else will be part of the outer if statement. So there are two things we can do. One is a shift, one is a reduce, and there's a conflict between them. So how do we solve this? Well, one simple solution is that tools just prioritize shift over reduce, right? And this is actually, turns out to be correct for this problem, right? The traditional solution to the if problem is that you always nest the else with the innermost if that it's possible to relate it to. So that corresponds to prioritizing shift over reduce, which is the default in a lot of tools. But that might not be what you want in all circumstances, right? It happens to work with if then else, but it's a little, you've been a little bit unclear with your specification, right? If you're relying on the priority of shifting versus reducing in the tool. So it's not a very satisfying problem. And in fact, most tools will warn you when this is going to happen. They'll say there's a shift-reduce conflict. Maybe you should fix your grammar to eliminate that conflict. So a simple approach that works with some tools is you can declare productions with precedence. And so, for example, you can give the if-then-else production a higher precedence than the if-then production. So this can be a good solution as well. Or if you want to be as clear as possible in your specification of the grammar, then you can rewrite the grammar to make it parsable in an LR1 parser. So let's look at how we could do that. Actually, this is an LR0 if-then-else grammar. So what we're going to do is we're going to say that a statement is either a balanced statement or an unbalanced statement. So a balanced statement includes an if then else that has where the then matches the else, right? And we're going to say that inside a balanced statement, everything's got to be balanced, right? Because if the things are unbalanced inside, then exactly where the else goes is unclear, right? So on the other hand, we do have unbalanced statements, so you can have an if condition then statement, or an if condition then balanced statement, but then an else of something that's unbalanced. So what's going on with this grammar? It's constructed in a very precise way to do the right thing. The intuition is that the balanced statements have matching then and else, and they can only contain other balanced statements. And so what that does is it forces unmatched thens to the outermost if statements, right? Because the unbalanced statement on the outside can have a balanced statement inside the then clause, but the else clause, but once you get into balanced statements, you can't have any more unbalanced statements inside them, right? Everything has to be balanced at the inner part, and then at some point you get unbalanced things. So this does solve the problem. It turns out that this grammar is LR0, but it's not LL0. So we can't use top-down parsing to parse this grammar. There are ways to solve the if-then-else problem in top-down parsers. Otherwise, the top-down parsers would hardly be used for any languages, because most languages actually have exactly this problem. But there's ways to do it. So you can use custom code to kind of look ahead and see, which way you want to go with the grammar, or you can use hacks. There's a notion called priority in ANTLR, for example, which is an LL parser. Priority happens to be exactly the opposite of precedence, so it's a little bit confusing, but it does work if you know how to use it. Priority just says, choose this production over some other production, but it's going to do it greedily when it starts working, rather than choosing between a shift and a reduce later on. So the eager versus laziness kind of reverses what you have to prioritize. ANTLR has some examples of how to handle if then else, so you can look at how that works. But recursive descent parsers can be handled with similar kind of hacks. But this is, one nice thing about LR is that it can handle more complicated grammars, such as this if then else problem. Now, if you are using an LR parser generator, you will sometimes get these conflicts, like the shift-reduce conflict that we talked about earlier with the naive description of if then else. You can also see reduce conflicts. And these can sometimes be a little bit tricky to deal with. So I have some advice. Start with a simple grammar that works, simple enough that you can get it right, even if it doesn't parse the whole language, and then add constructs incrementally, right? If you try to start with a language for the whole grammar for the whole language and fix it, it can be quite difficult to figure out. But if you add things one at a time, then much like any other kind of programming, it's a lot easier to make things work. So save and compile the grammar with your tool after each change. If there was some kind of conflict reported by the tool, then adjust the grammar to avoid it before proceeding. Now, how do you adjust it? You have to really figure out what's wrong, right? What is actually ambiguous about this grammar? You can try to reconstruct the LR parsing table. That will tell you exactly what went wrong, but understanding LR items at that level of detail can be a little bit intimidating, and it's typically not the fastest way to resolve the problem. So it's kind of a last-ditch effort that experts might go to, but it wouldn't necessarily be the first thing that I would go to in dealing with this. Something that's much better is to use a counterexample. So the best LR parser generators now provide counterexamples, and so they'll give you basically two different programs where that illustrate the conflict, right? Or they'll give you a program where the parser can't tell what to do and tell you at what point it's making that decision. And so these can be helpful in fixing the grammar. You can basically find out, where are things ambiguous, and reconstruct the grammar so that ambiguity can't happen. All right, let's do a check for our understanding. Give an example of a parsing problem that LR grammars can solve, but LL grammars can't.